Transverse, Reverse, and Normal Faults by Hannah, Whitney, and Zane. This is our plate that shows where all of our faults can be found. My fault is the transverse fault. This is the transverse fault. Transverse faults, also known as transform, strike slip, and lateral faults, is a fault that borders along a tectonic plate. You can find a transverse fault at a transverse boundary. Transverse faults usually move in a horizontal movement, but occasionally it moves in a vertical motion. This type of fault does move horizontally, but it also moves in the direction of the fault. This is a picture that I drew of a transverse fault before the slip occurs and after the slip occurs. Before the slip occurs, the two sections of rock are next to each other. In this picture, I am showing the shear force, the focus point, which is where the fault slips, and the epicenter, which is the point right above the focus point. As you can see, the shear force is pushing on opposite ends of the rock. My other picture is a transverse fault after the slip occurs. In this picture, each section of rock is being pushed the way the shear force was pushing it. Therefore, if the shear force was pushing rock section B forward, then after this slip occurs, rock section B would be forward. In a transverse fault, the rock sections slide past each other. When a transverse fault moves, there is a shear force that is pushing on the rock sections, which causes them to slide past each other. A shear force is a stress that is applied parallel or tangential to a face of a material. What makes a transverse fault different than a normal fault or a reverse fault is that the sections of rock slide horizontally, not diagonally. Transverse, normal, and reverse faults are alike because they all are a movement of rock caused by some kind of force. Though they look different, they all have common variables. They all include force to move, they all fold or crack under stress, and they all can occur on land. Most transverse faults can be found on the ocean floor where they cause spreading ridges that form a plate boundary like a zigzag. A spreading ridge is a fraction zone on the ocean floor where a molten mantle comes to the surface and creates new crust. Transverse faults also can occur on land. Some of the best known transverse faults were caused on land. One of these famous faults is the San Andreas Fault, which is in California. The San Andreas Fault was first identified in Northern California in 1895 by Andrew Lawson. In 1906, after the San Francisco earthquake, Lawson discovered that the fault also stretched into Southern California. Some other faults are the Middle East Dead Sea Transverse Fault, New Zealand's Alpine Fault, and the Pakistan's Sharman Fault. Preview. The next fault is the reverse fault. This is the reverse fault.
This is where the reverse fault occurs on our plate boundary. As you can see, it is reversed because the force is converging. A reverse fault occurs on a converging plate boundary. The hanging wall goes up and the footwall goes down. The only difference between a thrust fault and a reverse is that a thrust fault has a low dip with an angle less than about 45 degrees, where a reverse fault has a high angle. Normal faults are exactly the opposite of reverse faults. The difference between the two is that a normal fault's hanging wall goes down, and in a reverse fault, the hanging wall goes up. Also, reverse fault's force is converging and normal is diverging. Reverse faults are common in uplifting mountain ranges and along the coast of many regions bordering the Pacific Ocean.
In this part of our essay, we will be talking about normal faults. The normal fault is very similar to a reverse fault, aside from a couple key components. First, the force that is being used is not compression, but instead it is tension. Second, the footwall goes up, not the hanging wall, because the hanging wall slips down into the earth. Wikipedia stated that tension is the magnitude or the pulling force. A normal fault occurs where the lithosphere is being stretched or pulled. This can happen along a divergent plate boundary and will cause the footwall to jump up. A normal fault will always make the footwall move up and the hanging wall will move down. The average angle of a normal fault is 30 degrees, although they can happen to be at more or less degrees. The normal or inverse plates are also known as dip-slip faults. These kind of faults can be found on the ocean and on land. A normal fault is the same as the other two because they all can create earthquakes and they all move one way or the other. They are different because a reverse fault will move the hanging wall up while it moves the footwall down. But in a normal fault, the hanging wall moves down while the footwall moves up, and a transverse fault will just move forward and back, not up or down. There have been many cases of earthquakes caused by normal faults. One example of this is the earthquake in Alaska that killed about 200 people and destroyed Anchorage. This earthquake happened in 1964.